All right. So what we have here is the 2007 question 6. Guys, this is no calculator. No calculator on this question would be allowed. So it gives a function. Let f be the function defined by f of x equals some constant k times square root of x minus ln x. For x greater than 0, k is positive constant. In the first one, letter A, find f prime and f double prime. Everybody, I would argue you guys should be masters at finding these two derivatives. All right? So the first thing I would do with it, personally, if I'm taking the AP, is I want them to know that I know rational exponents. So I would start by rewriting the function. All right, now this is just a power rule problem, right? And knowing your derivative of ln x. Bring the power down, 1/2 k, x to the negative half. And what's the derivative of ln x? 1 over x. Guys, there's the first derivative. Now I probably should rewrite it in terms, all right? So I would probably write it over here then, and I would fix the radical. Because if you're taking the AP, you want to get used to doing this. All right? So I'm going to write that. But for the second derivative, I'm going to stick over here. And in fact, after I make that conversion, I might cross this off of my pen and put x to the negative 1 here. Because if I'm going to take the second derivative now, I'm just going to do the power rule of both. And I get negative 1/4 k x to the negative 3/2 plus x to the negative 2. All right? Again, over here, I'd probably take the second and write the radical form of that. Minus 1 minus k over 4 square root of x cubed. All right? Plus 1 over x squared. Everybody, on the AP scoring, these are each worth a point. The first and the second. So there's 2 points out of 9. Pretty quick, pretty easy. I'm going to need these derivatives for the rest of the problem. I'm going to group it all. That's letter A. All right? So again, every time you get these, my challenge to you is only spend 15, 20 minutes. All right? You should do this in 60, 70, 90 seconds. So you should have 7 minutes left right now. For what, the next question, for what value of the constant k does f have a critical point at x equals 1? For this value of k, determine whether k is a relative max, relative min, or neither at 1. Justify your answer. All right, let's just start with the first sentence. For what value of the constant k does it have a critical point? Obviously, for letter B, you have to understand, all right, you have to understand that a critical point occurs when f prime of x is equal to 0. There's a critical point. And they want that to happen where? At 1. So I actually would not use f of x. I would go f prime of 1 equals 0. That's the critical point. So I'll plug, so I go back up to my derivative here, right, and use that. So I go, here we go, 1/2, or maybe I would use the derivative over there, k over 2 square roots of x minus 1 over x equals 0, but I know x is what? 1, so I would change that x to a 1. So there's my first step, right? Does everybody see, then if I do the math here, I get k over 2 minus 1 equals 0. What's k got to be? K's got to be 2. Do you guys agree? So k equals 2. So we just found k. And everybody, your point so far is this was a point. That statement was a point. That's a point. So we're already 2 points in. There are 2 more points to go, but we've already earned 2 of the 4 on this problem just by knowing what a critical point is and finding k. All right, now it says, for that value of k, determine whether it's a max, min, or neither at 1. Well, you got to. It doesn't ask for whether it's max, min. It says determine whether it is. It doesn't ask for the max or min value. So I either got to use the first derivative rule or the second. Guys, do you guys all agree the first derivative is 0? So I'm going to find out. I'm going to just plug in 1 into the second derivative, because we know if it's negative or positive, with the first derivative being 0, it's going to tell us whether it's a max min, okay? So I plug that in to the second equation, f prime prime, where k is what? K is 2. So I got to plug two things in here to that equation. I got to plug in k is 2 and x is 1, and I got to see the sign. And I plug in negative 2 over 4 times the square root of 1 cubed is 1, plus 1 over 1 squared. Do you guys see it's negative half plus 1? And you know, negative half for the first term plus 1 for the second, so it's positive. You guys all agree? So all I care is that it's greater than 0. So what do we know? First derivative is 0. Second derivative is positive. So guess what we know for a given fact? Local min. Local min. Concave up. Picture a concave up curve. F has a relative minimum at x equals 1 with k equals 2. That's what I would write because I want to describe what the situation is. Why? Because of the second derivative rule. Boom. This is what you guys hate. You hate justification. Alright? But this is what proves we have the calculus. Alright? So we justified our answer. Now, what are the last 2 points? That a relative min was worth a point with no solution. That you showed this here, okay? It kind of all ties together. The last thing was that you used the second derivative test. That you gave the reason. The black reason. And that's letter B. So we've earned 6 points out of 9. And remember what I said. If you're making 6 out of 9, you're probably on your way to a solid 4, maybe even better. Alright? So there's A and B. And I don't think I need B for letter C. So let's put B up here and make it a little. Alright? Go back up the board. And start C. For a certain value of K, the constant, the graph of F has a point of inflection on the x-axis. Find this value of K. F prime prime of x equals 0. I agree. So that's probably the first thing I would want to write. You hit it right on the head. We'll do green. So F prime prime x equals 0. And the point, guys, you got the inflection point. The PI, you guys agree, is going to be x comma 0. Why is it comma 0? Because it's on the x-axis. All right? And I don't know if that's worth any points or not, but I definitely want to get what I know on paper. All right? So, I probably want to take the time and plug in and set the second derivative equal to 0 and find the value of k that works, all right? So, I would probably write 0 equals, right, the second derivative, negative k over 4, and maybe I would like x to the 3 halves. I like exponential powers, plus 1 over x squared. All right? At this point, a lot of students get very confused about what to do next. I think I got to find a common denominator. All right? Because, so I can get the top. So I see x squared as a common denominator. You guys see it there? So then if I multiply by x to the half, or 4x to the half, 4x squared, I'm sorry, x to the half, 4 and 4, right? And this is algebra 2, right? I mean, a lot of times this is the confusing point, but it's algebra 2, find a common denominator. So I can write 0 equals negative 4kx to the half plus 4 all over what? 4x squared. Guys, it can't be 0. Do you guys agree? X cannot be 0 because the denominator can't be 0. But if you're going to make it equal 0, what do we know about the numerator? It has to be 0. So at this point, I think I could write negative kx to the half plus 4 equals 0. Kx to the half equals 4. X to the half equals 4 over k. And how do I get rid of that? All right. Oh, I want to solve for k. What am I doing? I want k. I want k. So how about k equals 4 divided by the square root of x? I wouldn't rationalize, guys. For x to the half, right? K is there. Now this is the hardest problem. So now we have K, all right? But we want the actual value of this, right? We want the actual value of this. So, what else do we know? Well, I know that's the value of K. I also know that I have a point of inflection because I have two variables there, K and X. So what do I know? No, when I plug in X, what's Y? 0. So I have to go back, and if I go full screen for a second, I know when I plug in X, I get 0. So I have another equation to write now. I'm going to use the original equation, all right? And I can write 0 equals K squared of X minus ln X. You guys agree? Because I know that point of inflection occurred right here, X and 0. So I left X and 0. So I solved this for K, and I think K is ln X divided by square root of X. Move ln X to the other side, divided by square. So now I have two K's, right? K and K. So what do I know about the K's? They're the same. Do you all agree? So I'm going to go back so you guys can see it a little better. I'm going to go back to 75. Nope, I'm going to go back to 100. All right, and if I go down here, I can set the magic statement of ln X over square root of X equals 4 over square root of X. Now you know it's now you feel great about the AP problem, because what happens to square root of X is they just go away. And you get ln X equals 4. And now we get to test your pre-calc knowledge, because often this is where students bog down on pre-calc. We should know, again, that ln is log e x 4. So x is what? E to the 4th. If you're prepping for the AP, you better be able to do that up here. E to the 4th equals x, okay? We wouldn't have time to write that out. So, what is the point of inflection? The point of inflection is e to the 4th comma 0. And they asked for what value of K? So I'm going to go back. I know K is, I'll use that one. You could use the other one. It doesn't matter. I think that one's easier. So K is what? 4 over the square root of e to the 4th, which is 4 over e squared. And again, a lot of paper, a lot of writing. Do you agree? But there it is. So this one was a point for this statement. Boom. That was a point. Just saying the second derivative is 0 for point of inflection. Equation in one variable. So that was worth a point. And that was worth a point. And that was our 9 points. And again, these come with practice. That's why we're going through them here to start with. You don't usually get to see these and feel great about these until you practice a few of them.